Start with the givens. Now, these proofs. I honestly think a lot of you think these proofs are really hard because you get intimidated by what, by the fact that it is a proof. While I'm putting this up here, I would really like some of you to look at the picture and just don't think of it as a proof. Think of it as how is a way that you could explain to someone why AB is parallel to CD. Okay? It's like, I always like proofs because it's like a treasure map. You have to find the clue. There's a clue somewhere in the problem, normally in the givens. And something you've learned this year allows you to know those lines are parallel. So, what is it? Look at it while I'm doing this. Everything that was given is already, not marked. I'll mark it. One loop on these. Two loops on these. They are congruent. It will eventually be a converse. That's what it has to be to show lines are parallel, so good. It will eventually be a converse of some sort. Now, actually, let's go back to that. Let's start right there, Donovan. What kind of converse is it going to end up being? If AB, if this line, let me mark them in blue. If this line is going to end up being parallel to this line, which is what the proof is asking us to show, what kind of converse is it going to be? What kind of angles are formed there? Interior. You're exactly right. He is exactly right. The alternate interior angles converse says if these angles are congruent, the lines are parallel. But do we know they're congruent yet? There's nothing that links these two. So that's what we need to do. So he is working backwards, which is perfect. He knows that we're going to end up using the alternate interior angles converse. Kudos. How can we show these are congruent? Give you a hint. You're going to need angle 2 and angle 3 somehow. Yes! 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 Angle 2 and angle 3 are vertical angles. What are vertical angles with each other? Yes, 2 and 3. No. Look at your vertical angle theorem. Vertical angle theorem. In your notes. Look at it now. What does it say? They are congruent. Thank you. So, let's look at that for a second. Now, we're not ready to write this down as a proof. We will in just a moment. Actually, let's just do that. Let's go and make this step 2. Alright, here we go. Step 2. Angle 2 is congruent to angle 3 by the vertical angles theorem. Now, anytime you have all these congruences, what should you automatically be looking for? This is kind of a trick question. I'll give you a hint. We talked about a wrapper yesterday. Yes. Anytime you see that multiple things are congruent right next to each other, you need to be looking for TPOC, the transitive property. Are there any two that say they're congruent to the same one? Yes. Which two? Well, 1 and 3 both say they're congruent to the same thing, right? So by the transitive property, so angle 1 must be congruent to angle 3 by the transitive property. Now which two were we looking to connect? Donovan said earlier we're going to do alternate interior. Which two angles do we need to show for alternate interior? 1 and 4. Now, with the help of this, could we use transitive again to possibly link 1 and 4? What are they both congruent to? Angles 1 and angle 4 are both congruent to 3, and thus, by the transitive property, are congruent to each other. We only have one more step after this one. So that's transitive property again. The transitive property of congruence says that angle 1 is congruent to angle 4. Now we can do exactly what Donovan said in the beginning. And once we've shown that the alternate interior angles are congruent, which we've done, we can use the alternate interior angles converse to prove AB is parallel to CD. Hello? That's okay. So get that down, and one second. Equations of lines. Now there's two formulas the book wants me to give you, and one I'm just going to give you because it's going to make your life easier. But first, let's start with the two it's going to make me give you. First is slope-intercept formula of a line, which we'll talk more about after you've written it down. The slope-intercept form of a line. What you really need is the name of it and the equation. And you also probably wanted to know what M and B actually stand for. Write down those things that are underlined, and what they stand for, and that's what you need. Did you get your bag again? Didn't you forget your bag yesterday? Not today either. Do you need a pencil or anything? Oh. Okay. Has everybody got that written down? Just kidding. What? You learned this in you learned this in algebra? Ah, well then this is easy today. Good. Then this should be a walk in the park. Okay. Well, in this case, it's probably going to be reviewed for most of you, but we're still going to go over it. If it gives you the slope of a line, let's say it equals, that's way too steep. Let's say it gives you a slope of 2 and a y-intercept of -1. M is slope, b is the y-intercept. Here's how you can graph it. Go to your y-intercept, 0, -1. That's where it crosses the y-axis, hence why it's called the y-intercept. And then you're going to do the slope. Now, slope. Is this thing running 2 and rising 1 or rising 2 and running 1? Rising 2, running 1. Boom, boom, over. There's your dot. 1, 2, over. Connect your dots, and you can graph your line straighter than I did. It's hard, okay? This pad, you can't see what you're doing. Thank you, Sage. Luckily, I'm oblivious to sarcasm. That's how you use slope-intercept form. It gives you the slope, gives you the intercept, you just graph them. Questions on those? We're going to look at that some more, but I just wanted you to know what it was. All right, standard form. AX plus BY equals C. It's really all you need to write down there. Yes, it's AX plus BY equals, well, it's not a formula, it's a, well, yeah, it's a formula. I was going to say it's a form, but keyword in formula is form, so I'm not going to argue about the EULA. Standard form really isn't used that often, but I'll show you an example anyway. I don't think they even ask you to put your homework in standard form today, but oh, thank you. Now, here's how you're going to use standard. Here's basically, if they give you something like this, then, let me think. Yeah. Then it's in standard form. Yes, it is. Oh. If it gives you, oh, okay. If it gives you something like that, it's in standard form. Now, most of your homework is going to ask for things in slope-intercept form. Now, look at standard form and look at slope-intercept form. What is the most noticeable difference, other than the M and B? Like, what's the main difference you notice? Yes, that's exactly right. The only difference is that slope-intercept solves for y, and the other one doesn't. So, if they ever give you standard, let's say they give you an equation like this, and they say, hey, what's the slope and the y-intercept? Easiest thing to do, just solve for y. Just solve for y. If you subtract 3x from both sides, minus 3x plus 12, that's right. Divide by 4, and that gives you y equals negative 3/4 x. And what's 12 divided by 4? So boom, they ask you for the slope and the y-intercept. Solve for y. Your slope is negative 3/4. Your y-intercept is 3. Easy peasy. What's that? Was it? But I don't think it probably asked you for the same stuff. Okay. The one I'm going to give you, yeah. This is not in your book. You probably have seen this before too, but it's going to make your life a lot easier. It is called, this is going to be point slope form. Now, I'm going to try to put this in Spanish. Punto pendiente form? Is that right? Yeah. I'm learning. Well, he's nice enough to nod. So, that form, y minus y1 equals m times x minus x1. But notice, every formula so far has had an x and a y in it, right? That you never touched. That's not something you change. Same thing here. The x and the y aren't going to change. The only thing that are changing are the y1 and x1. Yeah. Okay. Now, here's why that formula is going to make things easier for you. Today, it's going to do things like you have a slope of 4 and a point of 2, negative 2. Notice, they're not giving us the y-intercept. And now if they give you a point to y-intercept, obviously use slope-intercept form. I meant slope and intercept, because then you can just plug in the slope, plug in the intercept, boom, there's your equation. But if they don't, you're going to have to solve for that y-intercept. But the easiest way to do that is using slope-intercept form. And here's how you do it. Y minus, what's our y value? Negative 2 equals our slope times x minus our x value, 2, point slope form. And to put that in slope-intercept form, all you have to do is solve for y. Multiply by your 4, add your 2, done. We'll go ahead and finish this. If it asked you to put a point, let's just get to some examples. That's how you use it. Let's look at some examples. Right here. This right here, you need point slope. Write an equation of the line passing through this point that is parallel to that line. Now, yesterday we talked about lines that were parallel, and what's the relationship between the slopes of parallel lines? Yes. They're the same. If two lines are parallel, they have the same slope. That is the only thing that you need from this equation. What is the slope of that line? Negative 4. Remember, y-intercept form, it's the number being multiplied by the x. Negative 4. Now all you need is that and this point, and we're off to the races. Y minus our y value, this is that point slope form I just gave you. This is the easiest way to do it. Point slope form. So y minus 4 equals the slope times x minus your x value. Now for the equation, they pretty much always wanted in slope-intercept form. So all we have to do, solve for y. So that's going to be y minus 4 equals negative 4 times x, negative 4 times negative 3. Now what do I need to do to solve for y? Add the 4. Add the 4 to both sides. Is that negative 4x plus 16? And you're done. And if they asked us for the y-intercept, what would the y-intercept be? That's the slope. 16. Very good. Y-intercept would be 16. And how would we, well, we'll graph it in a minute. So, parallel, they're the same. Guess what the next question is going to ask? Perpendicular. And perpendicular slopes are what with each other? Anybody remember how to find it? Yes. But when you're given the slope, how do you find a perpendicular slope? Flip it, change the sign. So, perpendicular. What is the perpendicular to this slope? Negative, you have to flip it too. Negative 1 over 4. Because remember, this is like 4 over 1. So, negative 1 over 4. That's all you need this equation for. It is no longer even relevant. Point slope form. Y minus negative 3, which is the same as y plus 3, equals the slope times x minus our x value. Remember, this is the point slope form I gave you 2 slides ago. Now all we have to do is solve for y and we're done. We'll have to subtract the 3. Good question. The 8, 3. Only thing we need from this one, see how they say perpendicular to this line? Only thing we need from that is the slope. So I use this to get my negative 1/4 because it's perpendicular. Just flip and change the sign, and then that's all I need from that equation. So, multiplying negative 1/4 times negative 8. Who can help me with that? We posited something. What's negative 1/4 times 2? It is 2. Now what do I do with this 3? Subtract it. Y equals negative 1/4 x. 2 minus 3, negative 1. We are rocking and a rolling. Intercept. Yes, it is. If it asked you to graph it, negative 1 would be where it crosses the y-axis. Actually, because it's negative, you would go down 1. Okay. Questions? All right. Now, all I did was put more examples on the board. These are exactly like the ones we just did. They're giving us a point and an equation. These 3 say parallel. These 3 say perpendicular. 1 through 6, is there one somebody would like to see that was more complicated than the others, like maybe one of the fractions? This one? Okay. So this one's parallel, this one's perpendicular. They're essentially the same type of problem, just that one little slope thing. So number 3. I'm going to take this one elsewhere. Number 3. So we need to go through that point parallel to that line. If it's parallel, who's going to come? Jensen, what's my slope of my new line going to be if it's parallel to this one? That's you, Elijah. Can you help him out? Malik? If my line's going to be parallel to this, what's my slope going to be? Yes. Yes. If it's parallel, it's the same. So it's just that number being multiplied by the x. Point slope form. Y minus our y value equals the slope times x minus negative 1, which is the same as plus 1. What do we have to do now? Solve for y, right. First thing you need to do actually is you want to go ahead and do your multiplication first. 2/3 x plus 2/3. Add the 2. Uh-oh. What on earth is 2/3 plus 2? You say 2 2/3? That's true. It actually is 2 2/3, but
Oh, it would be 8.
makes perfect sense. That's perfect. Remember, to convert a number to a fraction, just multiply the top and bottom by that denominator. So 3 times 3, that would make that 6/3. 2/3 plus 6/3 is 8/3. And there's that one. Questions? You need to know how to find these slopes. Elijah saved you. Jensen and Malik, I'm coming back to you in just a second. In fact, we're just going to knock through all these slopes real quick. Jensen! If it's parallel, what's the slope of this line going to be if it's parallel to that one? Yes. Jensen, what if I said perpendicular to that line? What would it be? Malik. You do, but you also negative 7/4. Let's see, who am I going to pick on there? But you guys know them. I wouldn't be picking on you. Elon, you've been awful quiet over there. What's perpendicular to this slope? That's parallel. What would be perpendicular to it? Negative 3/2. Okay, here we go. Graph. Now, they gave us an equation in standard form. But we know the easiest way to graph it is for it to be in slope-intercept form. So how can we put it in slope-intercept form? Yes, essentially solve for y, which is, I think, what you all are saying. So, subtract the 2x. I'll do it down here. That's 3y. That's a y. Equals negative 2x plus 18. It's okay if you put 18 minus 2x. It doesn't change anything. Now what do I need to do? Divide by 3. So that's going to be negative 2/3 x. What's 18 divided by 3? 6. Now, moment of truth. Cameron, what's my y-intercept? Yeah, that's right. It is 6. 1, 2, 3, 4. So you plot your y-intercept. 6. Now your slope, am I going to be going up or down? Down. So I'm going to go down 2/3. Maybe do it one more time for good measure. Since I know you guys really ridicule me over my bad lines, I'm going to use a line thingy. Well, you know what? Maybe if you guys weren't so mean. So there you go. There's your line. We have graphed it. Y-intercept, slope. There you go. You get where this came from? All we did was divide by the 3. Negative 2 divided by 3 is negative 2/3. 18 divided by 3 is 6. We did them individually. In fact, that's what you want to do. If you leave the whole thing over 3, it's going to kind of be a little confusing. Does somebody want to see another graphing problem? Let's do one more. Actually, let's work backwards from a graphing problem. We'll come back to that slide. Here we go. Now, we're going to work backwards from a graphing problem and then maybe graph one more. Write an equation for this line. Well, deadgum. What we need for an equation is a point. If we're going to start with point slope form, let's do number 3. We need a point, which we've got, but we also need what? The slope. How can we find the slope of that line? Did it yesterday. What? How can we find this? You can, but let's say the picture wasn't there and only the points were. How can you find what? Without looking at the picture. What are you saying? Rise over run, but what? Does anybody remember the formula for the slope yesterday? Yes, ma'am. That's exactly what it was. That's how you have to find the slope. So, here we go. It doesn't matter which one you use first. Let's do 4 minus negative 2, which is 4 plus 2. And then negative 3 minus 1. So that's 6 over negative 4, which reduces to what? 3. Negative 3 halves. Same difference. Kind of. Okay, now, don't reinvent the wheel here. We've got points to choose from. It doesn't even matter which one you choose. Pick a point, -3, 4, or 1, -2. 1, -2. It doesn't matter. You'll get the same thing. We're going to use that, one of the points, and the slope. We're going to use point-slope form, and then just solve for y. Y minus our y value, which will be +2 because it's minus -2, equals our slope times x minus our x value. Solve for y. And then we're done. Y plus 2. Why is that plus 3/2? That's right. Well, negative times negative. Right. Negative, negative, positive. Subtract dos. And what does y equal? Well, 3/2 x isn't going to change. What is 3/2 minus 2? What did you say? -1/2. That was the slope we got from this formula. That gave me +6 over -4, which would... Oh, you have to multiply through by this number in point-slope form. 3/2 times x and 3/2 times -1. Yes, ma'am. Oh, that's not a hand. That's a... Never mind. Okay. Questions? Now we're going to graph one more real quick, and then I'm going to cut you loose, and you're going to have tons of time to get this done. Graphing one more of them. Pick one to graph. Pick any of them.
8.
I heard 8 and 9.
8. 9.
9 it is. Really? You can be that guy? Okay. Solving for y. Subtract the 7x. Divide by 5. That's really ugly, but it's okay. What's -14/5 as a fraction? I mean, as a decimal. So, would you say that's about here-ish for the y-intercept? Here's the thing. I know not all of you are artists. You darn know I'm not an artist. Just make it close. I don't care if it's perfect. Okay. Now, is this going to go up or down? Right. So, you could go down and over, but then you're going to be way down here. So I'm going to choose to go the opposite direction. I'm going to go 7 up, 5 left. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Connect the dots. And you've got your line. Not very good at this. Ish. And you've graphed it. Solve for y, and then you have the y-intercept, you have the slope, and you're golden. Questions about that? Right, we're excited to do our homework in this class. Here you go.